So here's an interesting question. Can we make glass, here's a piece of glass, into a conductor? Everybody knows glass is an insulator, right? But I guess anything can conduct electricity if you put enough voltage on it, right? But it turns out that, there's a guy who invented something called the Nernst lamp, a guy named Nernst, actually, and he was taking ceramics and heating them up really hot, running electricity through them, and you could make an incandescent light bulb that didn't require a glass envelope because the ceramics are already oxidized. If you put tungsten in atmosphere and you heat it up to incandescent, it will oxidize and burn out. So glass also is an oxide, has a lot lower melting temperature. Do you think we could turn this into a conductor, put two electrodes on either side of it, and heat it up with electricity, make it conduct electricity? So very interesting project. Let's see what we can do here. See if we can turn a piece of glass into a Nernst lamp. Okay. Okay, let's talk for a second about the theory of the difference between conductors and insulators. So in quantum theory, there is a band where electrons can conduct, which is the upper band here, and then there's what they call the valence band, where if all the atoms have the electrons filled, there's no room for the electrons to conduct because electrons are fermions and they can only occupy one position at a time. Fermions cannot, unlike photons or bosons, fermions can only, they bump into each other. If something's occupying a position here, then another electron can't occupy the same position. Of course, you can have two of the different spins, but identical electrons cannot occupy the same position. Just like two people can't sit in the same chair, well, very easily. But in quantum mechanics, you couldn't do it at all. So what you can do, though, is if the conduction band and the valence band, these are energy levels that the electrons can be at, are very close together, it's very easy to excite an electron up into the conduction band so it can travel along, since they're overlapping or they're touching here. Now, in a semiconductor, they are separated. The conduction band and the valence band have a band gap between them, and you have to put some energy in the term of photons or heat or something like that to bump up the electrons into the conduction band, but not too much because they're very close. This energy level is very low. The difference between a semiconductor and an insulator is just a matter of extent of how big the band gap is, and not, it's basically, you can turn this into a conductor as well, an insulator, if you give it enough energy to knock the electrons up into the conduction band. And that's what we're going to try to do here by heating this glass up really hot. We're going to bump the electrons from the lower valence band up into the conduction band, and we'll see if we can get the electrons to flow inside of our pieces of glass. I have several pieces of glass here and some nails that I'm using for electrodes, and we will try this out. Very cool experiment, huh? Anyway, enough of the theory. Let's do something. Okay, hello, this is Dr. James, and today we're going to show you how to build a glass Nernst lamp. Okay, I got a couple nails and a piece of glass. Very cool. I don't think anyone's ever done this before. Let's take a look at this thing. Okay. Oh. Okay, so here we have our setup. I have my meter set to ohms, and it's infinite right now. I have two nails and a piece of glass in between. And let's try heating up this glass and seeing if the conductance changes. See if we can actually measure something on there. Should be interesting. Oops. Ooh, I gotta be careful with this. Okay, so here is our water torch. And let me change hands, hopefully without burning the house down. And let's see if we can heat this glass up. Keep an eye on the resistance up here. There we go. See that piece of glass? Oh, I measured the resistance for a second. Look at that. 1 point some mega ohms. Holy cow. 455 kilo ohms. Twenty-two, 27 kilo ohms. Okay, let me turn off the heat and we will see if the resistance goes back up. Overload. Look at that. So the glass seems to become conductive when it gets hot. Very interesting. So that seems to imply that we could probably use it to make a Nernst lamp out of. Very cool, huh? See, I wonder. Okay, so here we go. I have a piece of glass that, just a spare, I don't know, junk piece of glass that from one of my tubes I was making. Let's try sticking our electrodes inside of this. Come on. It's not fitting. Come on. Here, let me fiddle with this. I'll get both the electrodes in there. We'll see if we can melt the glass around them. Okay. Okay, so our resistance is infinite right now. And we got our torch here, and let's just try melting this glass around the nails. Maybe it's too big, I don't know. We'll see what we can do here. That gets really bright, doesn't it? We put this hydrogen torch on it. Okay, what is that? 2 mega ohms. It definitely looks like it would be possible to make a Nernst lamp out of a piece of glass. Let's see, we're down to about one mega ohm. See if I can get the resistance down even more by melting this glass better. Okay. Wow. We're at, well, it depends on, I guess, when I let it cool down a little bit. The resistance is coming back up. Oh, I blew out my torch. Okay, let's see. We'll watch it as it cools down. Watch the resistance climb back up. Okay. Look at that. Overload. Very cool, huh? Okay, I'm putting this on a piece of ceramic tile because this thing's probably going to get really freaking hot. And I've already done some measurements on it that show that the conductance of the glass becomes a lot lower when you heat it up. Maybe we'll see if we can get this thing to ignite. Very cool. Glass Nernst lamp. Okay, did I ever mention don't try this stuff at home unless you're a professional like me? Because this is, by definition, dangerous. Look at this. Here we go. We have a power strip, so I can turn it on and off here, with an extension cord with 2 clip leads on there. And you do not want those things to short together there. Wow. How does that look for super dangerous, huh? Oh my god. Okay, so let's add something even more dangerous to the mix. We'll bring our hydrogen torch over here, and we'll see if we can get this thing hot enough to conduct electricity. Oh, doesn't that look fun, huh? My torch blew out. Let me really relight it. I don't know, maybe I'm trying to heat up too big of a piece of glass. I don't know. The whole thing's got to be conducting. Oh. Okay, one thing's for sure, I can always show you good ways to blow out your voltmeters. And here I have my voltmeter on the milliamp scale connected in series with our Nernst lamp and our freaking power strip here. And we'll turn that thing on. And if this thing does take off, it will definitely blow the power meter, blow the fuse in there. I wonder, let me, okay. Here we got our torch here. We'll see if we can get the milliamps to go up at all. Which we should be able to if we can get enough heat into this thing to make it start conducting. Oops. Oh, my torch got turned off. That's why it's not heating up. Let me relight this. Okay. I had the power supply to my torch turned off, so let's try this again. Oh, look at that. Our current's starting to go up. We're at 30.30 milliamps. 50. Oh. 1 milliamp. Oh, we're up to 8. Well, I'm starting to see some sparks in there. $13, $15. Holy cow. Torch blew out. It looks like our milliamps are dropping. Okay, I think what we'd really like to do is maybe just melt a small piece of glass right in between these two electrodes. So let's see if I can do that. Holy cow, wow, look at that. Started to take off, and hopefully, I'm not sure, I might have blown the circuit on my voltmeter. Wow. Let me turn off the power. Oh, there you go, glass Nernst lamp. Now normally, like with my other Nernst lamp, you have to put a resistor in there to stabilize the current because it will start running away. The hotter it gets, the more current I'll put into it, the more current I'll put into it, the hotter it gets, and it will just be a runaway process, so you need a resistor to stabilize it. Okay. I'm not sure if I ruined my voltmeter or not. Okay, let's take a look here. Maybe I should put it on. Here's close-up mode. Have my 2 nails in there. And I took out the voltmeter because the voltmeter's got a fuse in it. And I might have blown the fuse, I don't know. It's a pain because I have to take it back apart. Sometimes you blow the voltmeter when you do that type of stuff too. Let's just see if we can do something cool with this guy here. Okay. Okay, here we go. There we go. Holy cow. Whoop. I think I blew the fuse. Wow. Anyway, that was pretty cool. Okay, so that is what our device is looking like now. It almost seems like the glass is getting colorized inside. I don't know. Anyway, maybe I'll stick a resistor in there and see if that stabilizes the reaction. Let's see what we got here. What do we got? I have to do some calculations. 10 ohms. Oh, is that going to be too low? 10 ohms, so 120 volts divided by 10 is 10, right? Is that 12 watts? Yeah, 120 divided by 1 ohm is 120 watts. I don't know. We'll try this and see if 10 ohms is too much or not. See if we can stabilize this thing. This one should be good up to 50 watts. So let's give that a shot. Okay, so here we go. I put a 10 ohm resistor in there in our circuit to limit the current to stabilize it. And here's our Nernst lamp, our glass Nernst lamp. And let's see if we can get it to light and be stable. Put the 10 ohm resistor in there. Oh, there we go. Look at that. It kind of fizzled out, but it lit for a second. Let me try lighting the torch and see if we can get it to go again. Okay. I can see sparks in there. Look at that. Okay. Well, maybe the 10 ohm resistor is too much. Let me try a few more times and see if we can get it to light stably. It's still glowing. Maybe I'll put another resistor in parallel with that to bring it down to 5 ohms and see how that works. Okay, so when you put two 10 ohm resistors in parallel, you get 5 ohms. I just measured it to make sure. Let's heat this guy up again. Okay, see, I can see an electrical discharge in there. Well, it's not really staying on in a stable way, though. Oh. Anyway. Okay, so we added a... Oh, got my torch going. I'm torching things I shouldn't. A high power 2 ohm resistor. So we're reducing the impedance. And let's see. Oh, I gotta turn the electricity on. Let's turn the electricity on. And try not to destroy something with this torch. Something that I don't want to destroy, at least. And we'll heat up this glass again. See if we can get this thing to conduct. Oh, it's making a noise. That's probably the torch. I think the electrodes are getting too far apart. They're melting apart. That's not good. Okay, I think I melted the glass too much and it's too far apart now. That's no good. Oops. Okay, I had to reposition the glass because it melted too far apart. And I got the electrodes closer again. Let's see if we can heat it up. And get this thing to light up. with electricity. Looks like it melted through again. Let me reconfigure the glass. Okay, here we go. I just set the one electrode on top of the other one, and gravity's going to pull them down together once the glass starts to melt. This could be a dangerous situation, but we'll see what happens. Something should happen at least. Oops. My torch blew out. Okay, we'll give this thing a shot again. Okay. Ooh, wow. Oh. Okay, so that was something. Phew, this resistor's getting kind of hot here. Ooh. Okay. I don't think they shorted together. I think there's still glass in between them. It just, yeah, look, they're pretty far apart. They didn't short together, but that glass became conductive and it put on a little fireworks show. Yeah, they're definitely not touching. Try to break those apart. We'll take a look at that. Still pretty hot, probably. Let's see, where is my... Yeah, see, they're not... There's still glass in between those two guys. Okay. It just started conducting a lot of electricity. I'll try that again. Maybe I'll let this resistor cool down for a little bit first, though. Okay, I think we might have cooked that resistor because it is now reading about 30 ohms. That's no good. Anyway, we'll switch it out with another one and try it again. Okay, so I kind of put the electrode back in the place it was before, kind of end to end, so you know that they can't fall down on top of each other. And got our torch here again. I'll try heating this thing up and see what happens. Oops, my torch blew out. Okay, let's take a look at that electrode. I don't know why it's getting so black up on the top. It shouldn't be turning black, I don't think. right now. Oh. Oh. There we go. Okay. Well, I'll have to try something else, I guess. Okay, here we go. I got tired of trying to melt that big piece of glass. I'm just going to put a little piece of glass between the contacts. And I believe I have the power on. So let's see what happens. We got our torch going. And we'll just try to melt this little bead between our contacts. Let's see what happens. Oops. Torch blew out. Okay, here we go. It seems like it's forming some kind of slag at the end of these electrodes where it's coming in contact with the glass, and that may be blocking the conductivity of the electrons. That's why I'm not getting anything. Before, when I did it the first time, I had a envelope of glass all the way around it so it was protected from air. I don't know, I'm trying to scrape this slag stuff off, and maybe I'll try a different experiment. Okay. Okay, so I cleaned off the electrodes with the corrosion, and I just got a small glass tube to put over there so I don't have to heat up very much glass. Maybe it was the corrosion or slag or whatever getting on them. Maybe it was because they got corroded. Anyway, a small piece of glass, it will be easier to heat it up. Got my torch going, got the high voltage on. Let's see if we can get this thing to light up like a light bulb. Oh. Okay. Try that again, I guess. Okay, here we go. Heat that bead of glass up again. See if we can get this thing to ignite. Oh. I don't seem to be able to get it to ignite again. Okay, I don't think I was getting the full voltage down to the electrodes because I think some of the electrodes weren't making good contact. I gotta try this again. I tried wiggling over. Oh. I guess that is... Oh. Oh. Well. Okay, so there we go. Holy cow. Yeah, our resistor's getting a little bit warm. Okay, I guess that's about as good as it's gonna get. There is your glass Nernst lamp. Holy cow. Higher resistance, so I wasn't able to get a good effect, and this one was exploding the glass. Oh my god. Okay. Okay, anyway, looks like kind of melted the end of our nails. Turn them into balls. I don't want those to drop on my pants or something. That would hurt. Anyway, oh, there's the glass. Looks like slag now. Very cool, huh? Okay, let's take a look at this stuff. Here we go. Let's see, where is it? It looks like a bunch of alloy of iron and glass, and it's really hard, and it melted right onto my ceramic tile here. And let's just, out of curiosity, check the resistance of this. See if it conducts any electricity at room temperature. And it seems like it does not. So I'm thinking might not be able to make a stable discharge because glass has a pretty low melting temperature, even though the conductivity of the glass goes down as you heat it up, so it can conduct electricity if you heat it up enough. So glass becomes a conductor when it gets hot enough. But it melts, and it, maybe if I used a different material, maybe if I used tungsten or something instead of iron, because the iron seems like it's melting. So the ends of the iron are big old glob there. They both melted into the glass, and it seemed to mix with the glass, and it seemed like it was catching on fire or something. Maybe the iron was burning, because I don't think the silicon dioxide can burn because it's already oxidized. Anyway, very cool experiment. We'll be doing more cool experiments. And anyway, so there's how you can make a glass Nernst lamp. Didn't quite work out the way I thought, but I think I'm going to move on to the next project. Looks a very dangerous thing, working with super hot HHO torches and high power directly from the outlet hooked up to things without much protection. Anyway, very cool experiment. Exploding glass, molten exploding glass. Anyway, this is Dr. James, and thanks for watching.